that's our, can you hear me well? Okay, so that's our project mapping eddy flow structures using GCM filters. And here's our team working by Zoom. So Nora and Paige were our mentors, and Anne and I, we also are the participants on this group. So the goal for this project were to apply the GCM filters to any car global high resolution ocean model fields. So basically it is a spatial filtering analysis that allow us to separate features in different scales. And with that, we can, for example, visualize how eddy flow structures evolve over time. And the last goal for this project was to evaluate the energy. And Anne and I, we are just starting learning Python and GitHub. And here are some new things, really interesting that we learned. So now we are much more comfortable with the workflow on GitHub, what will be very valuable for us in the future too. And we learned how to create different content environments for different projects, then we can maintain everything organized. And we also learned a lot of different tools on Python. So for example, we were able to open our data set directly from the Pangeo catalog, and we worked everything that we worked on was with X-Array. I do not have time to go through all this code right now, but I'd like to also show you that is our repository on GitHub, and we have been communicating through the issues, and so that's also a thing that is really interesting to learn. And I'd like to show you some moves that we did. So basically here in the first panel, we have the total data. And in the second panel, we have the filter data. So we use it 1 degree scale. So here is all the features that is bigger than 1 degree. And the last panel, we have all the features that is smaller than 1 degree. And if you go that over time, we can see here, for example, some structures being formed and propagating. So yeah, I found that's very cool. And we also calculate the energy, and then you talk a little more about that.
Yeah, so now I will talk a little more about the code and about the calculation of eddy kinetic energy applying GCM filters to the high resolution model. So here's some importing of the packets and the open of the data. And here we can see we applied a wet mask to our data for the filter to work. And next we made a desk chunk in latitude and longitude directions so that the way the chunks could not influence the spatial filtering. And we create, and here we create and applied GCM filters with scalar Laplacians. So there's the specifications of the filters. We create the filters and apply to the velocities and meridional and zonal direction. So here's the calculation of the mean kinetic energy and the eddy kinetic energy. So the mean kinetic energy is the kinetic energy associated with large scales, and the eddy kinetic energy is the energy associated with small scales. Next, we did some slicing of the data and we plot the results. And there you can see that the eddy kinetic energy focuses on regions that are more probably the occurrence of eddies, that eddies occur. And we had some trouble using CartPy, but we managed to solve it. by expanding a little bit our wet mask. And then we plot it out in the end. And we also made a movie to see how the kinetic energy evolves over time. But for our next steps, we plan to see how the kinetic energy evolves in longer time scales and compare the filtering of the velocity fields using scalar Laplacians and vector Laplacians. And we plan to use some tools that we learn on our future work. Thank you, everyone.
Fantastic. That's great. Okay.